Hello everyone and welcome back to our channel. We will be discussing the volume of solid of revolution. Now what is a solid of revolution? This is a solid that is generated by revolving a plane area about a line as known as the axis of rotation, or we can also call that as axis of revolution. So if I'm going to show a plane area, and this plane area which is shown in our figure will be revolved on a line L, which is known as the axis of revolution. So this will generate a solid. So if this is originally the area, so revolve about L, then the solid that is formed is this one. Now our concern is to determine the volume of the generated solid. There are several ways to arrive with the volume, and one of which is the method known as the circular disk method. We also have the circular ring or washer, the cylindrical shell, and by Pappus theorem or by secant proposition of Pappus, we can also arrive with the volume of the generated solid. Now I have to start with the circular disk method. When can we use or when can we apply the circular disk method? Now, a circular disk is formed if the dA, or the element of the area which is to be rotated, is perpendicular and tangent to the axis of revolution. I call that as ER. So, this is possible if our ER, or axis of revolution or rotation, is also a boundary to the region. So, this is a condition where we can form a circular disk. Now, imagine that we are constructing different rectangles over the region, and I'm considering one of the rectangle with a radius of r. This is what we call as a differential area. Now it has a thickness of dh, so it will generate a solid which is a circular disk if revolved about L. So take note that the dA that is to be revolved must be perpendicular to the axis of rotation. So when this is vertical, so ang imong dA will also be constructed horizontally, the length of which will serve as the radius of your disk, and the thickness of which is also the thickness of your circular disk. When that's revolved, so this is now the disk that is formed. Now how to get the volume of the disk? We call that as a differential volume. So the volume of the disk denoted with dV is equal to the area of this surface which is circular. So this is pi r squared, and you multiply that with the thickness to obtain the volume. Again, our r is the length of the differential area, or the length of the element of the area. Now for obtaining the total volume V of the solid, then it is actually the integral of your dV. So when we integrate, we have pi, we have limits of integration where the region is formed. So you can start from h1 to h2 and your r squared, okay, r squared and the dh. Okay, so we have a specific example. Now we are asked to find the volume of the generated solid by revolving the area bounded by the curves about the indicated axis. So the boundaries are 2y equal to x cubed, x equal to 2, and the line y equal to 0. Now, in A, so this area, which is bounded by this curve, will be revolved about the x-axis. Now, we notice that our x-axis has the equation of y equal to 0. Then, that means, ang ato ang boundary is also used as the axis of rotation. So, it's really possible that we can form or we can apply the circular disk method. Okay, so we have to start with the figure. So the figure form is this one, and the area which is bounded between the three curves, the y equal to 0, the x equal to 2, and the cubical curve is actually kini. Now, when the area will be revolved about the x-axis or a line y equal to 0, so x-axis being horizontal, so the strip to be constructed or the rectangular element must be positioned vertically. This will touch or rest on the axis of rotation. So the height of which is a variable height So this is actually a height of y because this is resting right on the x-axis. How about the thickness? The thickness of which is dx. Now, what is the volume of the disk when this is circular? So the volume of the disk is denoted with dv. So that is equal to pi y squared dx. Okay? So when we integrate, we can have the total volume v. So we can put our pi outside. Then we have the integral with a limits of integration for which the region is formed. So for the values of x, so you start with 0 up to 2 as limits of integration. Then we have the y squared, then dx. Okay? So, integrate. But before that, you have to express your y as a function of x. Now, you are given an equation here. 2y equal to x cubed. So, if you solve for y, then y is equal to x cubed over 2. Then that will be raised to power 2 and integrate. Okay? So, we have our v, which is equal to 32 over 7 pi cubic units. Now, in letter B, we are taking the same area, but the axis of rotation is x equal to 2. And x equal to 2 is also a boundary to the region because the condition for in using a circular disk is that our axis of rotation must also be a boundary to the region. Okay? So, if this is our area and our axis of rotation is x equal to 2, this is a vertical line. So, the strip that is to be considered or your DA must be horizontal. So, it must also rest on the axis of rotation, which is the line x equal to 2. Okay, so this is now your figure. And if revolved, then this is the disk that is formed. So, what is the thickness? Since this is horizontal strip, the thickness of which is dy, and the radius of that. The radius of that is the length of the strip, which is r. Okay? So, r then, a thickness of dy. What is the differential volume or the volume of the disk? dv is equal to pi r squared dy. Okay, so get the total volume by integration. So, there we have pi, we have the integral, at which tanaw na to, what are the values of y in which the region is formed? So, it starts with y equal to 0. So, this is a line, x-axis, whose equation is y equal to 0 up to what value of y? Okay, so the value of y here is 4. So, we have 0 to 4 as limits. How about our r? When this is positioned horizontally and this is resting between two curves, then our r is x at the right minus x at the left. And we have to convert this in terms of y to make it integrable. The x at the right is x equal to 2. So, imo ipuli diya. Then, how about the x at the left, which is the x of your cubical curve? So, if you have to simplify this, solving for x, then it can be a cube root of y to y, correct? So, put that into square and then integrate. So, you will arrive with the answer which is equal to 1.6 pi cubic units. Or in terms of fractional value, then it can be 8 over 5 pi cubic units as our answer. Okay? So, let's try with another example. See our area or our region is bounded by the two curves. What are the curves, sir? We have x squared equal to y cubed. This is a semi-cubical curve or a semi-parabolic curve or a semi-cubical parabola. Okay? So, another boundary is a horizontal line, y equal to 1. And it will be revolved on a line which is also a boundary to the region, which is equal to or y equal to 1. So, start with the graph. Okay, so let us show the region that is bounded by the given curves, and this is the region which is bounded by the curve. So, this is the graph of your semi-cubical parabola. Okay, so, with this as the region, okay, so if this is the axis of rotation, which is horizontal, then the strip to be constructed must be vertical. Okay? So, the height of which, or the length of which, we call that as r. Okay? So, what is really your r? Okay, but how about the formula for the volume of the disk? The volume of the disk, by the way, is equal to pi r squared with the thickness which is dx. Okay? So, dv is equal to pi r squared dx. So, integrate to obtain the total volume. Okay, so we have pi, then you can consider the limits of integration for which the region is formed. What are the values of x for which this region is formed? It starts with -1. Up to what value of x? We have 1. Okay, so r squared dx, but in the other expression here, you will say that there is 2 before pi. Now, so if there's 2 there, it is because we are changing the limit from 0 to 1. 0 to 1 is only half of the region. So that means we are applying the symmetry of our figure by providing a factor to her. So the limits, pwede tamo sugod from 0 only up to 1. And you can insert 2 due to symmetry. Now, expressing your r in terms of x, or what is our r in our figure when this is also resting vertically in between two curves. So, your r there can be y at the upper minus y at the lower. Now, expressing your y in terms of x, the upper y is a constant 1, then the lower y in terms of x from the equation. So, if you solve for y here, then we can take a cube root both sides. Then, our x will be raised to power 2/3. Correct? So, entirely, raise this to power 2. And from your calculator, you will arrive with a value which is 1.436 cubic units. Now, if you want to arrive with a value which is an exact value, so we can integrate by formula. Okay, so we can have our v which is equal to 2 pi, and we have the integral with limits of 0 to 1, and we have the square of the difference of the upper y minus the lower y. What is y at the upper? Again, it's 1 minus x to power 2/3. Okay, that is in square. So I can expand before I can do the integration or applying the formula of integration. What is the expanded form? I have 1. This is twice the product. Okay, so we have 2x to power 2/3 and the square of the last term. Okay, so that is x to power 4/3. Okay, so if we integrate, then this is equal to x. This is 2x to power 5/3, correct? So divide with 5/3, or that can be minus 6/5 as a constant coefficient of your x to power 5/3. Now, increasing the power here from originally x to the power of 4/3, if we increase the power by 1, then the exponent becomes 7/3. So, it's divided with 7/3. So, just take the reciprocal for the constant coefficient. I can make use of a coefficient directly 3/7 to simplify. Now, with limits of integration from 0 to 1, okay, so with the upper limit being substituted to your x, my first term is having a value of 1. My second term has a value which is minus 6/5. My third term has a value of 3/7. When 0 is substituted, every term has an expression x. So, the function value there becomes 0. So, combining them, okay, and simplifying the result, then we arrive with a volume which is equal to 16/35 pi cubic units, which is actually having an approximate value which is the same as our previous answer. Okay, the third. So this is actually intended to show a derivation of a common geometric figure. Okay, we are asked to find the volume of a sphere with radius r. So just to show a sphere, okay, say this is having a radius of r. What is the volume of the sphere? Okay, now, let us try to consider a semicircle with radius r, which will be revolved about its base to form a sphere. Okay, say we have a semicircle, which is like this. Now, in order to have an equation of a circle which is simpler to look, then I just let the center of my circle to coincide with the origin. So this is my x-axis and that is my y-axis. This is a semicircle, and if we try to recall, the equation of a circle with center at the origin and radius is r is equal to x squared plus y squared equal to r squared. Correct? Okay, now when you solve for your y, so you have the square root of r squared minus x squared. There is supposed to be plus and minus. The positive is the upper branch, the negative is the lower branch. But what I need is only a semicircle, because if that is revolved about this axis, then that's the time you can generate a solid known as the sphere with a radius r. Okay? Now I can call this as y. So if revolve about x, which is horizontal, then I have to construct my strip vertically. Since it rests on the x-axis, then the height of which is y. The thickness is dx. So what is our dv? The dv, which is the volume of the disk, or the disk volume, is equal to pi r squared. Your r is equal to y, then dx. Get the total volume by integration. So our volume is equal to, so there is a factor to here, because the limit of integration, pwede man nato ma-express from minus r to r, but I'm only considering half of my area. So I start with the value of x from 0 to r as my limit. So I consider the symmetry of my figure by multiplying the result with 2. Okay, so 0 to r. So my function is already y squared. So if that's y squared, then y squared is also equivalent to the square of this, which is a difference of r squared minus x squared. So we can integrate with the variable x. What is the integral of your first term? So r squared x, correct? This is under power rule, so we have minus x cubed over 3. The limits of integration is from 0 to r. So we substitute r to x, then this becomes r cubed. This is minus r cubed also over 3, and that is both zeros. Okay? So simplifying or combining 1 and 1/3, or 1 minus 1/3, then this is 2/3 of r cubed. The 2/3 of r cubed, if multiplied to 2 pi, will give you the formula for the volume of the sphere, which is equal to 4 over 3 pi r cubed. Okay, so this is a derivation of the formula of the volume for sphere. Okay, so thank you for watching, and I'm inviting you again to subscribe to my channel if you are new to my channel, and if you are already subscribing with my channel, so please be kind to share this also to others. Okay, so thank you for being around. Good day and bye-bye.